Hi everyone, post is here. So it's been about 3 to 4 weeks since my last post is here video, and stuff's mounting up, so yeah, I think it's about time to do one. So this video contains 1, 2, 3, 4, 5 items. I think I usually do about 4 to 6 items. This one's got 5. So let's start. This is the first item. I'll just zoom in so you can see it a bit better. There we go. And what is this? Let's have a quick look at it. It appears to be an SD card. Oh, here you go. Micro SD card adapter. So, here you go. Chip select, serial clock, master out, slave in, master in, slave out, VCC and ground. Micro SD card adapter. So, seems common sense to me that this is a way to store data while using the Arduino. So you'd put an SD card in there, and then you'd connect this via SPI. That is, it's not I2C, it's SPI. And then, well, it's common sense, isn't it? You'd be able to store data, and I would imagine you'd be able to read it back into the Arduino. So that's quite useful. I'm actually quite excited about this because that will be a very interesting future project. So just before I carry on, let's have a quick look at these chips here. LVC125A, never heard of that. And this other one here, this will probably be an AMS1117, is it? Can't quite get the light to shine where I need it to, but I can see with my eye that it is AMS1117 3.3, which means that's a voltage regulator. So this regulates the voltage, and this obviously does the processing, well, basically the saving of the data that will come in through here into the SD card and reading from the SD card back out to the Arduino. So that's an interesting little device. I'm not sure how much I paid for it, but anyway, let's move on to the next. Okay, the next item is this, and this is, well, it looks like a lock. So let's have a look. So you've got what looks like a lock there. So yeah, it's like a barrel thing. So what you would do is you'd have a steel plate, probably. You'd drill a hole into the steel plate of that diameter. You'd put that in, and then there's a nut there. The nut would go the other side, and you screw that in, or you'd actually screw it in from the back until it gets tight, and then you put the key in and turn it. But of course, this isn't an ordinary lock, it's an electronic thing. It's actually not a lock at all, it's a switch. So you put the key in, and then turn the key. If it will turn, there you go. Well, it's quite a nice feeling lock as well. There's a bit of a spring to it. Anyway, and what happens is, like I said, it's not a lock at all, it's actually a switch. So if I just get my multimeter, and I'll have to put this on resistance mode, of course. So resistance, it will be 200 ohms max. And I'll connect this to here, and connect the other one to here. And now what will happen here is we'll get a short and an open circuit. So let's see. So currently, well, there you go. So there's the short circuit or closed circuit, and there's the open circuit. So yeah, it's a switch. That's quite an interesting little thing, that's why I bought it. Anyway, that's that item. Just put that back in its bag. And what's next? I think next we'll go for this. Okay, I'll just have to rip this open. And let's see. Okay, I'll need to zoom in. It's quite a small item. Right, I don't know if it's... oh, there you go. The camera can make it out. 24 LC64, and it's got a little M there. That's Microchip's logo. So it's Microchip 24 LC64, and I believe that's an EEPROM, which is an electronically erasable, programmable read-only memory, EEPROM. And basically it's just a little memory storage thing, a bit like the SD card, which I've just shown you here. Only I would imagine this will be, it obviously doesn't need a little chip like that, and it of course doesn't rely on an SD card. It's built in, but it won't have as much memory potentially as the SD card, but I think it will be a lot faster. And this will probably be an I2C device, or yeah, I would say I2C, but I'm not 100% sure yet. So yeah, in a nutshell, this is a very small memory storage device. With it saying 64, I would imagine it's 64 kilobits or kilobytes, or I doubt it would be 64 meg. But anyway, that's the next device. But actually, just before I finish with that, this thing's interesting for, useful for storing maybe parameters and stuff. So, for example, in my solar project, I could probably store configuration settings onto this little chip and then read them back whenever the thing's power cycled. Anyway, moving on now. Next I have this, and what is this? Let's just zoom out to start with. What's this? It doesn't look at all familiar, so it's something that's got a load of pins, a potentiometer, an analog 0, 1 and 2 pin, and an LED jumper there, and it's also got a power LED. What is that? It's something that's I2C, so I assume it outputs something maybe, or then again it could be input. Let's see what that says. PCF 8574T. I think this may be something to do with an LCD screen. Well, you know those little LCD panels which have blocks. So let me just see if I can find one. Where would they be? No, I don't know. I'm gonna just go to the eBay listing afterwards, and we'll find out exactly what this is and how it works. Yeah, at the moment I don't know too much about this one. I'll move on. The final item is this. Now, this does look interesting because I know a lot of you love RF stuff, and so do I. In fact, one of my RF videos is one of my most popular videos I've ever done, which it had a crazy amount of views, in the tens of thousands if I remember rightly. So yeah, I know you guys love RF. Anyway, what is this? So this is, well, I don't know, let's see. Let's have a look at this to start with. 433M, okay, so that'll be 433 megahertz. Yeah, it's got hertz there. ASK, which if I remember rightly stands for amplitude shift key, which I believe is the algorithm that it uses to encode and decode, or something like that anyway. And then STX 882 and SRX 882, that doesn't mean a great deal to me, but I know that TX means transmit and RX means receive, so I think that's just the models of the transmitter and receiver. Anyway, put that to one side, and let's see what this, let's have a closer look. I have a feeling this is one of those things called, in fact I don't know if I'll be able to pronounce it because I can't remember exactly what it's called, Superheterodyne or something like that. I'll have to read it and find out. Anyway, let's have a look. So I'll zoom in a bit more. That's a bit better. So this is the transmitter, and it's got R433A written on it. So we've got data, VCC and ground. You can't get any simpler than that. Oh, there you go, yeah. STX transmitter. It's got some tiny components on it, and presumably that hole out the top right, that's for the aerial or the antenna, and there's the antenna there. So I'll zoom out again now so you can just have a quick look at this again. Yeah, so the antenna would be soldered onto there. Now I've done videos on this before, these sorts of things, and I found that these antennae were actually not very good, but who knows, with this model they might be. So yeah, the antenna goes on there like that. What I did for my last one, or what I found was most successful, is using a quarter wave whip, not these coils. But anyway, there's the transmitter, I'll just leave that there. Let's have a look at the receiver, so I'll need to zoom in again. So what have we got here? We've got a chip which is PT4303-S. So a quick look to see who it was made by. I don't know if the camera will focus. PTC it seems to say. And we've got a 3-pin capacitor, or well, actually it probably isn't a capacitor, it's probably, I don't know, a resonator or something, I don't know, who knows. Maybe one of you will know. We've got a space for an antenna again over here. So yeah, now let's have a look at the other side, find out what these are. So we've got ANT for antenna, then we've got ground, data, CS which is chip select, VCC, and then we've got the 3 pins which go to that whatever it is. Then we've got ground and antenna again, so presumably that depends on the orientation. So if I was going to have my device that way up, then obviously I'd have the antenna there, like that. And if I was going to have it the other way, I'd have the antenna there, like that. And I suppose if you're going to have it that way, you could use either. Anyway, so that's what I've bought, and now let's go into the eBay and see what we've got in terms of prices. Okay, so it's time to find out a bit more about these modules and to see how much I got them for and where from. So to start with, micro SD storage board SDTF card memory shield module SPI for Arduino new from China, and the seller was Superheterodyne 65. You might want to check the spelling on that if you look for the seller. And the module cost me 23 US cents or 17p, and that's almost incomprehensible. That's just ridiculous. I mean, to put it into perspective, if I was to send a letter, basically an envelope with a couple of sheets of paper in, to my next door neighbour using using a company called Royal Mail, which is the standard for the UK, it would cost me around about 60p. So yeah, that's 60p to get a letter from anywhere in the UK to anywhere else in the UK. Now, as you can see here, this was 17p with free postage, and not only has it come from China, also using the UK network, which is called Royal Mail, like I just said, they've also supplied the product for that price as well. Now, in my opinion, that's absolutely ridiculous. But anyway, 17p, there you go, and I got the module, no problems. Anyway, more about the module itself. Let's have a quick look. Right, baby description. Okay, baby description. The module is an SD card reader module through the file system on SPI interface driver. Okay, I've got a feeling it's not going to be worth me reading through all this. So it accepts 5 volt or 3.3 volts power supply. Is there anything interesting here? No. Basically, you put the SD card in and you interface with this thing using SPI, which is Serial Preferable Interface, and you can get it working. Probably more on that on another video specific to this module. Anyway, the next one. This is on-off metal security key switch lock plus keys to position SPST best. And this cost me 38p plus, you know, whatever that is, probably another 30 odd p, so it's about 70p. So it's cost me 70p to get that from Shanghai, from a seller called jewelry.garden. And let's see if it says anything interesting about this. It's got the rated voltage, yeah, the panel cutout diameter, key can be removed in on or off position, and there's a huge picture of it there, and the keys. And that's it for that product. The next one is this. Now, I wasn't too sure what this was. So it says one piece IIC, I2C or I2C serial interface board module for Arduino LCD 1602 LCD 2004 display. Now, I'm just going to copy that because I'm going to have a look at that in a minute. So there's an image over there of the product, and let's see if there's any info. Weight, colour, yeah, I'm not too bothered about that. Backlight, alright, with backlight power control can be set through the jumper cap where the backlight power supply connect or not. Right. Contrast can be adjusted, rotate blue potentiometer. Right, okay. I'm starting to get an idea of what this thing actually is now. I think what you do is you plug it into, well, you solder it into an LCD, and you can control it all without having to use all of those pins or a lot of pins on the Arduino, because you can see here it's I2C. So I think the idea is you can control an LCD just by using 2 pins on the Arduino instead of all of these pins. But anyway, let's just have a quick look. Let's see what this comes up with. Images. Yeah, it's one of those things. So I imagine, oh look, there's a photo there. So I imagine that the pins along the top get soldered into that and you go from there. And there's a picture of it there, let's have a look. Yeah, that's very interesting. So I might have a go at that thing at some point. Anyway, so I can't remember if I said where it was from. This particular one, I couldn't actually find the listing from the actual item I bought, but this is £1 here anyway, from China, from Kingful-Electronic-Company. And the next item says the model number EEPROM IC serial 64K, and it was £1.09. Now this is a British store, Mallinson-Electrical, so this is from the UK, from Huddersfield. And let's see what it says about this. Memory chip, 8-pin DIL, which is dual inline, if I remember rightly. It's serial. That is interesting. Right, no, hang on. It's got different interface types. It seems. It seems that it's I2C and possibly serial as well. I'm not exactly sure how that would work. Memory size 64,000 bits. And it's got the number of pins, etc. So that's that thing. Again, that will be in another video some point soon, I'd imagine. And the next one is this thing. And it says 433 megahertz, and then the models, ASC, wireless transceiver, Superheterodyne. Superheterodyne. I'm not exactly sure what that means. Super obviously means strong or something. Hetero means different, opposite, something like that. And dyne, dynamic, fast. I don't know. Big, different, fast. Again, I'll Google that in a second. So I got this from Chipworld, £2.13 with free delivery. And there it is. Let's see what it says. It's a low-cost, small-size, ultra-high power, low harmonic amplitude shift key, I think, transmitter module. Has a high stability and high cost. Alright. 3.6 volts power to achieve 50 milliwatts, is that? It's currently on the market under the same voltage, transmit power, whatever. Right, so remote. Oh no, it's got some applications and then some technical details. Quite impressive technical details actually. Okay. Yeah, that's actually some very nice documentation there. Anyway, so there you go. That's what I've been buying, and they are the products. Now, I said I'd Google this word here. I think it means probably something like strong, different, fast. I don't know. Superheterodyne. Let's have a look. Denoting or using a system of radio and television reception in which the receiver produces a tunable signal which is combined with the incoming signal to produce a predetermined intermediate frequency on which most of the amplification is formed. Yeah, but I didn't want that. I wanted the etymology.